Hi, I'm Dion from leavingcertmathsvideos.com. Now for question 1, nearly every single year you're going to have to know the difference of two squares, and especially for this one. The difference of two squares means that x squared minus 1 is equal to x plus 1 times x minus 1. So x squared minus 1 is equal to x plus 1 x minus 1. So for this part of the question here, we're just going to find the lowest common denominator. So our lowest common denominator of all these three terms is x plus 1 times x minus 1. Now, what we do here, x minus 1 goes into this term here, x plus 1 times. And then we have to multiply it by x plus 1. And x plus 1 goes into this term, x plus 1 goes into this term, x minus 1 times. That's x minus 1, and that's minus by the way. And that is x minus 1 times. And then we have here x minus 1 goes into this term once, so it's just minus 4. So we have to really just tidy this up then, so it's equal to this, and when we tidy that up, it's equal to x squared plus 2x plus 1 minus brackets x squared minus 2x plus 1 minus 4, and that is all over x plus 1 times x minus 1. Now we can see here that these x squared will cancel. I'm just going to keep it in brackets for a minute. But this x squared here will cancel with this x squared here. And this 2x and that 2x will make 4x. But this plus 1 will cancel with the negative 1. So basically what we're left with is 4x minus 4 all over x plus 1 times x minus 1. Now remember, you can factorize the top because 4 is common in 4x and negative 4. So we can factorize that. So just take out the 4, that's equal to x minus 1, all over x minus 1 times x plus 1. Now any number divided by itself is equal to 1. So that means that's just equal to 1. So your answer is 4 all over x plus 1. This is the solution to part A. Now on to part B. We're asked to prove the factor theorem for ax squared plus bx plus c. And we're asked to prove that if f of k is equal to 0, prove that x minus k is a factor of f of x. So what we do here is we prove that x minus k is a factor of f of x minus f of k. So we'll just write that down. F of x minus f of k. So f of x is equal to ax squared plus bx plus c minus f of k. Oh, sorry, that should be k. Minus brackets ak squared plus bk plus c. So we just tidy that up. It's equal to ax squared plus bx. Now the 2c, let's write the c down here, plus c minus ax squared minus bk minus c. Now as you can see, the minus c and the plus c will just equal to 0, so we're going to get rid of that. Now, we're going to factorize the a here is equal to a into x squared minus, so it should be k, x squared minus k squared, and plus b into x minus k. So then we know that this is x minus k, x plus k. So that is equal to a into x minus k times x plus k plus b times x plus k, or x minus k, sorry. So then we have here, that x minus k is common in both of these. So that implies that x minus k into a times x plus k plus b, and that implies that x minus k is a factor of f of x minus f of k. When we're told at the very start that f brackets k is equal to 0, So that implies that x minus k is a factor of f of x. Because we've proven that it's a factor of f of x minus f of k, and then we've proven that f of k is equal to 0, so then that proves that it is a factor of f of x. So on to the next part of the question, find values in which x plus k is a factor of g of x equal to x to the power of n plus k to the power of n. So we just started off here, we know if x plus k is a factor, then x equal to k is a solution. Sorry, x equals negative k. So we'll just write that down. Negative k to the power of n plus k to the n. Now we'll try this with odd and even numbers of k, or n, sorry. At n equals even. Right, when n is even, here we're going to have, say k is equal to negative 1, that means that the term is going to be positive. So for any even number, you're going to get a positive term here. So for n equal to 2, you're going to get negative, or you're going to get k to the power of n plus k to the power of n. So that implies that when n is even, you're going to have k to the power of n plus k to the power of n is equal to 2k to the power of n, which is not equal to 0. So we're going to try it now for k is odd. N equals odd, sorry. Now when n equals to odd, we're going to have an odd term here. We're going to keep the minus because, like say, negative 1 to the power of 3 is going to equal to negative 1. So that is, when n is odd, that means negative k to the power of n, because basically it's always going to be a negative, plus k to the power of n is equal to 0. So we're asked to find values for n which satisfy that. So n would be an element of 1, comma 3, comma 5, all the way up to 2n minus 1. And that satisfies the equation. So if you found this video useful, please add me on Facebook or Twitter or subscribe to my YouTube channel. Thank you.